Good morning, Chirag sir.
Yeah, good morning, madam. I am available.
Start within 5 minutes.
Okay, not an issue.
Yes, sir. Good morning, Jadhav sir.
No, ma'am.
Hello, good morning, madam.
Sir, we'll start within 2-3 minutes.
Yeah.
Okay, sir. Hello, Shraddha madam. Hello.
Hello, ma'am. Am I audible?
Yes. We can start.
Okay, ma'am.
Yeah.
A very good morning to all. I am Ms. Shraddha Bingardive on behalf of JSPN's Rajarshi Shahu College of Engineering, Department of Electronics and Telecommunication. Take this opportunity and extend my warm welcome to all the dignitaries and participants for Day 4 AICT sponsored 2-week online FDP on artificial intelligence and its applications in biomedical engineering. The speaker for today is Dr. Chirag Paunwala sir. Sir has completed his Bachelor of Engineering in Electronics Engineering from Sarvajanik College of Engineering, Surat in 1999. He has completed ME in Digital Techniques and Instrumentation under QIP category from SGSITS Indore and PhD from National Institute of Technology, Surat in 2012. Sir is currently Professor, EC Department and Dean R&D and at SCET Surat. His area of specialization is biomedical signal processing, pattern recognition, image and video processing. Sir has published papers in international peer-reviewed journals with high impact factor. He has 8 book chapters and also published 70 plus research articles in excellent peer-reviewed international journals and conferences. Under his leadership, Chapter won the Chapter of the Year award twice for consecutive 2 years, out of approximate 200 chapters worldwide, which was the first time in the history of IEEE SPS USA. Sir was the youngest and first recipient of the Regional Meritorious Service Award for Service and Leadership in Signal Processing Society 2017. He, he has also served as Chapter Chair Coordinator for Membership Board IEEE SPS USA for the year 2019. Sir has worked as a reviewer of technical journals as IEEE, Springer, elsewhere ACM. Sir has received grant of worth USD 4,000 twice for IEEE SPS for performing various activities. He has also received travel grant for ICASSP 2060 Shanghai, 2017 USA, 2018 Canada, 2019 UK, and currently he is a senior member of IEEE, fellow member of IETE, member ACM, and life member of Indian Unit of Pattern Recognition and Artificial Intelligence. Sir is the chief guest editor for Scopus Indexed Springer book on biomedical signal and image processing with artificial intelligence and IoT applications for healthcare systems. Sir is also serving as guest editor for Scopus Index special issue on applications of soft computing and machine learning techniques for biomedical signal and images. Sir, on behalf of JSPM's Rajarshi Shahu College of Engineering, I welcome you, sir.
Thank you, madam. Thank you for the nice introduction. So now, without wasting much time, I am sharing my screen and delivering a session. So, is my screen visible to all of you?
Yes, sir.
Okay. So, today's talk, as per the title of the FDP, we are highlighting for the biomedical image processing. And my today's topic will be on the non-invasive COVID-19 detection technique. And uh, today I'm going to highlight total 3 approaches related to COVID-19 detection. So our task is actually to help the society with the help of by doing some research related to the COVID-19. And we did the experimentation uh, on the 2 approaches. One is the tonsillitis based COVID-19 detection, which is the mass detection technique. Another one is the COVID-19 detection using the X-ray images. That is the second, we can say that second level of authentication that person has COVID or not. So why we are not going for the thermal detection, because many people are or the many in at the many places like malls, as well as the we can say that in the railway stations or the airports, they are using the thermal detection technique for the early diagnosis. But why we are not going for that, and why we are choosing the novel tonsillitis detection, which was really novel, and no one has worked uh, for that COVID tonsillitis detection for the COVID-19. So what is this unique in the tonsillitis that can be helpful to us for the COVID-19 detection, and how can we detect the COVID based on the tonsillitis? That is the one of the agenda. another agenda is that X-ray images, with the help of the X-ray images, how accurately we can identify the COVID patient. So let's start with first slide. So motivation behind the work is, as I have suggested, that we want to detect the COVID patient in the early stage, so that spreading can be stopped. And based on that, there are two techniques, as I told you, thermal detection as well as the tonsillitis detection. So why thermal is not and tonsillitis is there? So before starting with that, there are so many approaches through which we can identify that COVID is there or not. So there are two basic approaches: non-invasive methods and the invasive methods. And in the case of the non-invasive methods, see, obviously we are preferring the non-invasive methods for early detection, because invasive methods, as all of us are aware, that it can take a time to give the answer, but it can give you the correct answer. Here in the non-invasive method, we can have the probability of 80 to 90% that person has COVID or not. But in that after invasive method, we can have the 100% idea that person has COVID or not. So we have two techniques. There are so many techniques: chest X-ray, CT, thermal screening, and the tonsillitis. So we are concentrating on the chest X-ray as well as the tonsillitis detection for this work. Now, what is the shortcoming of the thermal screening technique? So, main shortcoming of the thermal screening technique is that person can wish that if he or she cannot, if person is interested to travel, then he or she can take the paracetamol tablet and he or she can travel, and that is uh, uh, detected many times, and it was there in the Times of India also, that this way person is doing the traveling, and thermal screening is failure because of the paracetamol tablet they are taking, and that's why we are going for the mass detection technique using the tonsillitis. Now, COVID-19 diagnosis from chest radiography images using deep residual network, that is our first approach. And uh, this approach was selected, or it was appreciated by IIT Kharagpur in the 11th International Conference on the Computing, Communication and Networking Technologies. And generally, my tendency is to uh, disclose the work after, if it is appreciated by community. So as this work is appreciated by the community, then after we have started to disclose this work. And obviously, in this work, for the COVID-19 detection based work, we have a team of total seven uh, researchers with us, including doctors. Because when you are saying that person has COVID or not, as an engineer, we can analyze with the help of the some deep learning or some image processing technique. But the final diagnosis or the final authority is with the doctors. So we have doctors associated with us in the panel of researchers also, and based on that, we did our work. Now here you can see that there are two sets of the images. One set is related to the healthy chest X-rays. Another one is related to the COVID infected chest X-rays. So now we have to identify what are the things that we have to look when we are saying that person has COVID or not. So here you can see that there are so many white spots visible. So based on that white spots, one can visually identify if person has severe COVID. But when the person has COVID in the initial stage, it cannot be easily detected with the help of the chest X-ray also. Now, what is the novelty of the approach? Novelty of the approach, when we have initiated this work, basically I want to give some brief about that initialization of our work. So this work we have initiated in the mid of the May, uh, when we had a lockdown, and during lockdown uh, we have started the work with the X-ray as well as the tonsillitis both together. And as we are aware that to get the images of the X-ray as well as the tonsillitis at that time was very difficult. and we got the chest X-ray images of healthy person, which was very simple. But to get the chest X-ray images of the COVID patients was slightly tough. So we had started our work with the limited data set. And obviously, when you are talking that you are working with the biomedical signal or image processing, you must have the high accuracy. High accuracy, what I am saying, that more than 90% accuracy. So you want the high accuracy. So for getting the higher accuracy, you have to use the deep learning method. But when you are using the deep learning method, the constraint is that you must have the large size of the data set. And as there is a popular saying that deep learning is the data hungry. So we have to work with the limited data set as well as we want the high accuracy. So how we have achieved that thing? So as mentioned over here that training sample with the open source data set was limited, and then also we have to achieve the high performance. The second one is that in proposed method we have the issue of the class imbalance, because as I told you, we have the limited data set of the COVID patients, but we have the large data size of the healthy patient. So that is the class imbalance. We have around 200 images of the COVID patients, but 1200 images of the healthy person. And we have to work with this data set. So how to solve the class imbalance issue? So that also discussed over here. Another thing is that when we are using the deep learning method, many of you are working in the deep learning or the neural network. So you may be aware that when you are working with the deep learning, to increase the accuracy, we are going deeper and deeper. But when you are going deeper and deeper, then the back propagation we have to obviously do for the setting the weight. So when we are doing the back propagation, there is a problem of the vanishing or the exploding gradient when we have the very deep architecture. So when we are going for the very deep, then the accuracy will be saturated, or it can be start degrading also. So because of that, because of this issue, we have to choose a method in which we can preserve or increase the accuracy, as well as we don't have the problem of vanishing gradient. So these two things we have to take care. So now, based on that, uh, I will start with my technique. So as mentioned, that drawback of the very deep neural network is, now I'm not discussing class imbalance. Now we are going for the very deep neural network. Very deep neural network means we want to increase the accuracy. But the problem is that when we are going deeper and deeper, we have the problem of vanishing gradient as well as the problem of accuracy degradation. So how to overcome these problems? Now, this is the slide in which it is mentioning that if I am using the suppose 3 convolution networks and one fully connected network with the softmax, and I am getting some accuracy X%. Now, in the second case, I am increasing the layers, but the layers that I am increasing are the identity layers. And then after I have fully connected layer, and then after softmax. So this is general architecture of any uh, neural network or the any convolution neural network. Now can you tell me, by mentioning in the chat window, what should be the accuracy when I am going deeper by adding the identity layer? So just you have to mention that accuracy is increased or reduced, or it will remain as it is. So I am requesting to write in the chat window. So you can write down the answer, that whether it is same it will be increased or it will be reduced in the chat window. Okay, anyway, so that is the general scenario when we have the online series. So anyway, when you are having the accuracy, when you are going deeper and deeper with the identity layers, your accuracy will remain as it is. Accuracy will not increase or decrease, because when you are going deeper and deeper with the identity layers, then it is just a multiply by 1 with the convolution parameters, that parameters coming out from the third layer, so that it is multiplied by 1 means we are not adding any parameters. And when we are not adding any parameters and just adding the identity layers, we have the accuracy same, that was in the previous case. So accuracy is equal to X%. Now, when I am not using the identity layer, but if I am using the convolution layers instead of the identity layer, then what should be the case? So if anybody is there, then he or she can give me the answer. What should be the accuracy? It will be increased, decreased, or it will remain as it is if I increase the convolution layers instead of the identity layers. Okay, some people are saying that increase and or the decrease. So exactly, when you are increasing the convolution layers, the accuracy will be reduced. So that is the drawback, that why we are not going much more deeper in neural network, because when you are going deeper and deeper, as I have mentioned earlier, we have the problem of vanishing gradient, and because of that vanishing gradient, weights are not updated as per the desired outcome, and that's why our accuracy during the testing or the validation will be reduced. So that convolution layer, if we are adding, then you have to add the convolution layer with some precautions. So going deeper is advantageous, but going deeper is also disadvantageous because of the vanishing gradient. So we have to go deeper also because of the accuracy, and we don't have to go deeper because of the vanishing gradient. So what is the solution? So we have to come to the solution. So before coming towards the explaining you the solution, we are going that okay, there is a question, but I think that question I will take later on, so that continuity is there in the lecture.
Yes, sir. Question will ask end the session at the end of the
Okay,
session.
thank you. So here you can see, maybe the question will be answered automatically during the session. So here you can see, when you are going deeper, here we have 20 layers. So you are aware that VGG 16 is there, VGG 19 is there. So when we are going deeper, then we have some training error. And when we are going more and more deeper, then we have 56 layers. Suppose we are taking 56 layers. It can be more than that. So here you can see that training error is increased compared to 20 layer, and that is proved by he et al. And this paper, deep residual learning for image recognition, in the CVPR 2015. And as per this paper, they have proved that when you are using more number of layers, then error will be increased. Training error as well as the testing or the validation error So it is increased dramatically when you are moving from 20 to 56 layer, and the iterations they have used are 10,000, 20,000, 30,000. So they have used the large number of iterations so that they get the good picture about the accuracy degradation or the error increment in the error. And this paper, many of you may aware that this paper is the in the top 3 citation in the Google Scholar. It has around 62,000 citations on the Google Scholar. So this is very popular paper uh, of he et al. And they are, if I'm not wrong, they are the researchers of the Microsoft. Now, moving towards the next one. Now, what is the solution? So now we are identifying the solution. So we are moving towards the solution. And for finding out the solution, we are taking the input x to y through one layer. So h of x is the mapping function that we want to learn. H of x is the mapping function that we want to learn. Now, what is the solution that we are giving? We are giving part of the input to the output. So now we have another mapping function, that is f of x. So f of x is nothing but the, actually it is h of x, which is f of x plus x. It's addition. So we are adding the input x to the output y before using the ReLU function. So here we have f of x, that is the residual. F of x is the residual function, that is h of x minus x, that is h of x minus x. And this residual function will help us to increase the accuracy. Now, residual architecture adds identity connection. As we have mentioned in the one of the slide, that we have, when we are adding the identity layers, there is no increment in the parameter. So what we are doing, after layers, after two layers, we are adding the input x to the output of the second layer before ReLU, so that we are adding the input back to the output, so that we have the input parameter with us, so accuracy can be maintained. Now, residual block in detail. Now, here, as I have mentioned, that there is no identity connection, there is no weight assigned, means there is identity connection. So there is no new parameter that we have to train. Okay, hence there is no computational burden, because when you are adding the layers, it will add the computational burden. And we want to, when we have the computational burden, then finally we have to dump our algorithm or our network on the GPU or the hardware. At that time, this parameter, increment in the parameter will affect the mode. So we want to make parameter efficient method, because generally when we are using the GPU like a Jetson Nano or the TX1 or the TX2, at that time we have to deal with the parameters also. So we want to make the system parameter efficient, as well as we want to make it accurate. So now this method allows us to design deeper networks in order to deal with the much complicated problems and tasks like biomedical applications. So here we can go more deeper, because accuracy will also be maintained or the increased. And as I told you earlier, we want the higher accuracy in the case of the biomedical applications. So this type of the deeper network with the residual block will be helpful to maintain the desired criteria. Now, this slide is very important to understand that how the vanishing gradient problem is solved, and how accuracy will be maintained. Here some maths is associated with this slide. So there are three layers. There are three layers. Just I'm taking one pen and try to highlight. So layer L minus 2, L minus 1, and L. So these three layers are there, and we want to work at the layer L for the forward propagation. So we have the in output coming from layer L minus 1 with the some weight L, and that outcome associated with A is A into sorry, A of L minus 1 plus bias of Lth layer. Similarly, we have identity layer. So this is the forward path for the identity layer. So the weight associated with the forward path is WL minus 2L into output of layer L minus 2. Output of layer L minus 2. So this is output of layer L minus 2. So this is coming at this position. Now, just I am representing this particular thing WL minus 1L into AL minus 1 plus BL as ZL. It's the outcome of the Z layer. And this is WL minus 2L into AL minus 2. Here we can't write that ZL minus 1, or sorry, ZL minus 2, because bias is not associated with it. So we have WL minus 2L into AL minus 2. Now here in the third equation, you can see that in the third, it's a AL over here. Here it's AL. So in the third equation, you can observe that WL minus 2 is equal to 1. We are setting it equal to 1 because we are assuming that it is the same dimension. We are assuming the same dimension. Same dimension means the size of the image after filtering, or the size of the image of the after filtering is not, or the after convolution layer is not changed, and that's why we are assuming that WL minus 2L equal to 1, and that's why it is the identity layer. Okay, now when we are going like this, we have outcome, we have input to the Zth layer from L minus 1 also, and the part of the output of the L minus 2 also. So here layer L can be learned more parameters. Layer L can be learned more parameters because of the layer L minus 2 also, because it has to learn the weight using L minus 1, but L minus 2 will also help L because of the parameters that are assigned to layer L using this identity layer, and that's why the weight updated at the layer L will be more efficient. So accuracy will be maintained as well as the weight updation will be fast, so that the number of epochs will be required are less. Now we are going for the backward flow, and this backward flow is very important when we are talking about the uh, vanishing gradient problem. Vanishing gradient problem means when we want, suppose we want the some outcome y cap, we want some outcome y, and we are getting some outcome y cap. So we have to take the error, square error. We have to take some square error. Okay, so we have to take some square error, and based on that, we have to do the back propagation. So in the back propagation path, we can have the way it is working, that delta L is the error passing from the layer L. Delta L is the layer passing from the layer L, and it is propagated. If possible, I'm changing the pen if possible. Hope that this is visible. Okay, so now we have to work with the back propagation. So it will follow this path. Obviously, this is direct path. We are saying that this is direct path. It has to follow. And this is the second path that it has to follow. Now, when we are following the direct path and we are taking the gradient, so at some level, gradient is reducing, and that is the exponential reduction, because when we are taking the difference and when we are taking the difference derivative of that gradient, when we are taking derivative of that difference, then it will be still less. And when we are going deeper and deeper from, suppose, uh, nth layer nth layer to the first layer, then it will be multiplied. It will be multiplied. And when you are going from the last layer to the first layer, then ultimately it can be the case in the first layer update can be 0.01 or can be 0. So there is no weight update. So when there is no weight update, then it affects entire layer. So that when you are going into the iteration, then ultimately your weight will be not updated and you are moving into the infinite loop. So this, to reduce this problem, what we are doing, we are passing the this path to the particularly over here. So how it will work? So this is the difference of the weight or the change in the weight, delta W, of the L minus 1 layer. So it can be from the minus sign indicates the difference. Suppose you want to change, if you want to add, then you have to minus, else it is plus. So weight updation will be because of this minus sign. So minus A L minus 1 into delta L, that is the normal path. Now it will be update the weight at this location. It will update the weight at this location. But if because of the deeper layer there is no weight update at this particular location, suppose I am assuming that there is no weight update, that means 0. So ultimately you will go into the infinite loop. So how to overcome this problem? This particular layer will help us, and that is added with this 0 or the minimum weight update, so that we can have some delta weight update over here, and this will ultimately preserve the back propagation, and the problem of vanishing gradient will be removed. So this is very important slide, and based on that now we are going for the Resnet architecture. Now this Resnet architecture was proposed by he et al. In the 2015, and here you can see that they have first they have compared their work with the 34 layer plane network. They gave the name plane network. They compared their work with the 34 layer plane network, and then after they have designed the 34 layer residual network. So in the plane network, when they are going deeper and deeper after 34 layer, and they are finally applying the fully connected layer for the 1000 classes, because they have to work for the contest of the ImageNet dataset as well as the COCA dataset. And for the ImageNet dataset, there are total 1000 classes, and they have to develop an algorithm or the network which can classify these 1000 classes with minimal error. So this contest is organizing by CVPR every year, and uh, the winner will be announced every time. So we can say that starting from the Google Net in the 2000 Google Net, then VGG 16, and then after 2015 Resnet, in which they have the error less than 3%, and that error is very much less compared to the previous winner, so that they got the exact classification. Now, the plane layers, when they are using, as we had seen earlier, the error was very large using the 56 layer. So now in the 34 layer also there was a layer, the error was very large. So what they did, they used the skip connection. This is known as the skip connection. So they use the skip connection. So with the help of this skip connection, they are using the skip after two blocks. As I have mentioned earlier, after two blocks, they are sending the outcome to this input of the third layer. And similarly, over here. So this skip connection is identity layer, and this is identity layer because here you can observe that we have 64 uh, filters over here and the 64 over here also. So because of that, there is no change in the size. There is no change in the size of the image in the subsequent layer. So we can multiply it by the 1, and multiply by 1 means identity layer. So there is no need of the additional parameter. But when you are going from 64 to 128, you can observe that here we have dotted line. We have dotted line. So this dotted line indicates that there is a dimension mismatch. There is a dimension mismatch. So we have to take care about that dimension. So in the next slide, I will explain that how to maintain that dimension. Then after, again we are traveling into the 128. Again we are traveling into the 128. So when we are traveling into the 128, we have again identity layers, means 1 because there is no dimension mismatch. But again when we are moving towards the 256, we have one dotted layer. Then after, again we have identity layers because we are running into the 256 only. Then after we are moving from 256 to 512. So again one dotted layer. So this dotted layer will take care about the dimensionality mismatch. Now how this dotted layer works. So here we can see that dotted layer has some skip weight, that is known as the skip weight. So when we are moving from lower dimension to the higher dimension, we have to multiply the layer with some weights. Initially in the identity layer, this ws was there, but it was equal to 1. So it was identity layer. But now we have to assign some weight. So when we are moving from 64 to 128, we have to multiply by the 2. And when we are moving from the 128 to 256, we have to again multiply by 2. So weight we have to update when we are moving from the one dimension to another dimension, and that can be demonstrated by dotted line so that we can understand that we have to update the weight. Okay, so that is about the skip connections weight. Okay, now next one. Okay, now in the next slide, here we can observe that we have the two networks. One network is the plane network and another one is the Resnet. So in the plane network, we use the 18 layers and the 34 layers both. So here 34 layers indicated with the red line or the red graph and 18 layer with the cyan graph. So we can see that the error is less in the 18 layers and error is more in the 34 layers. Means accuracy is decreased when we are going deeper and deeper with the plane connections. But when we use the ResNet, the scene is totally reversed. In the 18th layer, the error is something, but the 34 has the error drastically reduced. And then after author has tried the experimentation with the 50 layers also, 100 layers also, 152 layers also, and subsequently. Then after, now our proposed algorithm based on the ResNet. So ResNet is basically very useful when we want we want to maintain the accuracy. So now here up to this point we use the pre-trained ResNet layer. The reason to use the pre-trained ResNet layer is that we have the limited data set. And as we have the limited data set, and we want to work it for the COVID-19 detection, we want to work it fast as well as accurate. So we use the pre-trained layer network of the original paper, and here we have the two level of the classification only. That is either person has COVID or not COVID. So we have liberty now. Liberty, they have to classify 1,000 classes. So they don't want to make it complicated. So they used only one dense layer or the fully connected layer. Here we have liberty to go more deeper. So we are using more dense layers than after. And then after we use the more dense layer, and that's why we got the higher accuracy. So now we have the liberty because of the because of that we have only two classes to differentiate. Now, what are the key challenges and what are the solutions that for that challenges? So, main key challenge is that class imbalance issue. So, class imbalance issue can be solved by the weighted loss as well as the resampling. Now, class imbalance, as I have told you, and again I am explaining you in the brief, that class imbalance is the non-equal class of two categories. In our case, it's a COVID, in which we have around the 200 images, and non-COVID in that are we have around the 1,000 images. So we have to overcome that class imbalance problem before training, so that we have two solutions for the same, that is weighted loss and the resampling, and we have choose the weighted loss. We didn't use the resampling, but I am explaining you resampling also, so you can use it in your application. So in the resampling, generally if suppose you have 8 images in your data set, and out of these 8 images, 6 images of the healthy person, and the 2 images of the COVID person, then what you have to do, you can remove out of 6 images, you can remove 2 images out of 6 images randomly, so it will be 4 images only, as well as you can add 2 images of the COVID patient by repeating the uh, original images. So just repeating the original images once. So we have the instead of the 2, we have now 4 images, as well as now we have suppose non-COVID patient, then we have the 3 images. Okay, there are some questions, but I think that I will take after this COVID, particularly this topic before tonsillitis. Then after weighted loss, we are assigning weight to the classes, and then after we are doing the training. So that's where we are removing the class imbalance issue. Then data set size. Data set size can be overcome by transfer learning that we've seen right now. Then data augmentation, that generally I'm not preferring, because chest X-ray is not possible to have the issue of the translation or the rotation or the some scaling and like that. So the third one is the one-shot learning that we have used in our tonsillitis based detection, and that work is selected in the reputed Indicon conference 2020, and we have to present that work uh, just on the day after tomorrow. Now, class imbalance issue. Now I am going to discuss with the class imbalance issue. So in the case of the class imbalance, the higher value is there when we are finding out the loss, when we are going for the back propagation, at that time we have to calculate the loss function. So loss function will incline towards the higher value, or it will give the higher value to the dominant class. In our case, it is non-COVID person, and it will give you the lower value to the remaining class. Means when our weight will be updated after certain epochs, it will give more important or the more weightage to the non-COVID person. Similarly, our algorithm will be bent toward the uh, bent towards the means our learning features will be more dominant towards the healthy person. So generally we are using the binary class entropy for the calculating the loss. Now, if we have the class imbalance issue, then then how binary cross entropy is not useful, that we are looking. So we are calculating the loss with the standard equations. So loss can be calculated by a minus log of p y equal to 1, that is label 1, and y equal to 0, that means label 0. So now suppose we have the image of the COVID patient and we are assigning the label 1 for the COVID patient, and the outcome y that we got, that is y cap, that we got is 0.2, means it is not the correct answer. So there is a loss associated with this. So if we are calculating the loss, then the loss is 0.7 using this equation. Okay, so that is what the drawback. Now, second one is the uh, healthy person. So here we want the label 0, and instead of label 0, we want the outcome 0.7. Outcome we got the 0.7. So after calculation, we got the loss 0.52. So these are the loss, how to measure the loss. These are the methods that how to measure the loss. Now we are going into the detail about the class imbalance. So here you can see that we have total 8 images, and out of these 8 images we have 2 images of the COVID patients, and the prediction probability in the last case I have explained with the probability of 0.2 and the 0.7, but I have assumed that now all class have the equal prediction probability, that is 0.5. So why I am doing this? Just to have the easy calculation. So the loss that I am getting, that is 0.3. Loss you can calculate. This is binary weighted loss. Loss you can calculate using the previous equations. So this is the binary weighted loss. Now, now we have to sum all the losses. So total loss of the COVID person is 2 times it is there. So 0.3, and over here again the 0.3. So we have over here 0.6. And non-COVID person has the same error, but there are total 6 persons. So we have total loss 1.8. So for COVID person, the loss indicates that 0.6, and non-COVID it is indicating that it is 1.8. Means it is inclined more towards the non-COVID person. So optimization will be biased. Optimization will be biased towards the normal person, and this results into the class imbalance. So we have to come for the solution. So now solution is that we have to assign weights to both the uh, classes. Suppose we have the COVID class with the label 1, we have to assign the weight of the non-COVID, means normal persons. And when we are talking about the class 0, means non-COVID, then we have to assign the weight of the positive persons. So WN indicates the weight of the normal class, WP indicates the weight for the COVID class. So how to find out this weight? It's a simple. Suppose non-COVID or the normal is total 6 patient. So it's a 6 divided by total patient, that is 8. And in this case, we have 2 that are the COVID patient divided by 8. So this way we have to assign the weight to the normal equation, normal loss equation. Now we can see that what happened with the same example that we had seen in the last slide. So here we can see the same example. Using the binary weighted, we have lost 0.3. All the losses are 0.3. Now weighted binary, we have 2 divided by 8 for the normal person. Why 2 divided by 8? Because for normal person, we have to identify the weight for the COVID. So there are 2 COVID patients divided by total 8%. So 2 divided by 8 into 0.3. So it's a 0.075. And similarly for all the normal persons. Now, when we are coming towards the COVID person, it's a 6 divided by 8. Why 6? Because we have the total data set of the non-COVID person is 6. So it's a 6 divided by 8. So the value is 0.225. Now again, we have to calculate the total loss. So total loss of the COVID patient. So total loss of COVID patient is now 0.225 multiplied by 2. So it's a 0.45. And here we have 0.075 multiplied by 6. So again, it is 0.45. So now we can see that loss is not biased towards the non-COVID patient. So what we got? We got some solution. And that's why the class imbalance problem, which is actually the major problem, can be solved by using the weighted uh, binary classification or the weighted binary cross entropy loss. Now data set and the model training. Now we had around 182 COVID patients data set and we have 1341 normal data set. So here you can see that we got the data set from the IEEE data pot. Generally, I am preferring the standard data set if it is available. If it is not available, then you can go for your own data set, because in the case of the tonsillitis, we have to generate our own data set. So in that case, it is okay. But generally, if it is available, use the standard data set. And if you are not aware, then I am saying that try to choose the IEEE data pot for the data set. Many researchers are giving their data set for free on the IEEE data pot. That IEEE will check that data set and they will keep it over there for free access to all the IEEE members. So IEEE data pot, and just you have to cite in your work, that is obviously there. So IEEE data pot gives the 182 COVID patients data set. Then after this is the training parameter. We have number of epochs trained, that is 10. As I told you, we use the pre-trained, and that is what the advantage to us. Pre-trained is there, so we don't have to do much exercise for the weight updation. We use the base size 32 optimizer. These are the standard things. Okay. Now accuracy. This is very important thing. So we got accuracy of around 98, 97%, and the loss is also drastically reduced. So we can see over here that loss is also less. Training and the validation. Generally, you have to use the validation parameters for the calculation of the loss and the accuracy, because testing will not give you this type of the graph. Okay, so this is about the, and after just we got this graph after just 10 epochs. It can be increased if we are going into the detail, but our task over here is to give the solution which is accurate as well as fast, as well as parameter efficient. So there are so many constraints when we are working with the biomedical. Okay, and that's why it is so popular. So we are always happy when we are getting the solution. So sensitivity, these are some evaluation parameters that we use in our work. So sensitivity, that is the useful to identify the correctly predicted positives to the actual positives. So sensitivity is one of the important parameter. Then specificity, that is the negative out of total number of negative, because we also don't want that negative person will be identified as a positive. Some of the evaluation parameters are the positive prediction value, means true positive divided by true positive plus false positive. So it's a probability that a patient is infectious. Then negative predicted value means probability that a patient is healthy. So that is what the negative predicted value. Then false negative rate. This also should be taken care, because we don't want to identify the falsely negative or the falsely positive. So false negative divided by, or the ratio of false negative to the false negative plus true positive. Similarly, accuracy, that is the most important, as I narrated already. True positive plus true negative divided by total number of samples. And F1 score generally in the image processing, or we can say deep learning, we are measuring. It gives the overall performance of the system. So it's a 2 into precision into recall divided by precision plus recall. Now, just the result. Here we are getting the accuracy around 97.5% and the sensitivity of around 96%, and the PPV is also 99%. And this all the things we got with the limited data set. So it may be increased now by increasing the data set size as well as by going more deeper training. So conclusion is that based on this work, that uh, residual learning network can be used for the COVID-19 detection, as well as residual network is useful for uh, accuracy part, to maintain the accuracy or to overcome the problem of accuracy reduction by increasing the depth of the network, as well as it can be helpful us to overcome the problem of the vanishing gradient. We use the weighted cross entropy, and this weighted cross entropy is also useful for overcome the problem of the class imbalance. And this proposed algorithm gives the good answer for the quantitative as well as the qualitative parameters. So this is related to chest X-ray analysis. Now, still we have time of the 15 minutes. So if organizer wishes, then I will take the answers Q&A first of all, or I will take the second part first of all. So as per the need of the organizer, I will start my topic. Should I go with the Q&A? Okay, let me start with the Q&A. When Dr. Suresh Rathod, can we add dropout layers in increased convolution layers? Yeah, we can add dropout layer, but in the case of Resnet, there is no need of the dropout layers, because dropout ultimately useful when we are not going in so much deep, just like a VGG 16 or VGG 19. If we are not able to, if you are not satisfying with the answer, or if you want to discuss, you can unmute and you can discuss with me. Are anomaly detection methods useful in this case? Anurag, can you explain me what you want to ask me with this question? Okay, later on, maybe he's not available. So now I'm starting with the next part, that is the image processing based approach for the using the tonsillitis. So yeah, we can use. But if I wish that if you want to elaborate your question by unmuting yourself.
Sir, can you just
Yes,
can you
yes,
suggest
Professor.
other methods for this class imbalance problems?
You want particularly for some application?
Yeah, I want for the seizure detection.
Oh, seizure detection. In the case of the seizure detection, Anurag ji, I think that have you faced this issue, that class imbalance? Because there is a available data set with the balanced class. I think you are aware that is uh, one of the data set is the bond data set. Are you aware about this bond data set?
Yes, I use the bond data set. But in long time recordings, this problem comes.
Okay. So your work is in the time series analysis.
Yes, sir.
Okay. Now there are some solutions also, but that I can say that as per your application, we can discuss it later on, because it is exactly that application that I am also working for my one of the research scholar, that is the seizure detection. But still now we are not facing this issue because we are not going for the real time. And we are working with the bond data set as well as the MIT data set that we have received for the children. So we are working with this two data set right now. And as we are not working in the real time, so we didn't face this problem right now. But you can remain in touch with me through mail or the WhatsApp. We can discuss it later on also about the some other solutions available with me related to your application.
Okay, sir. Thank you, sir.
Okay. Now,
Thank you.
okay? What is the tonsillitis? So tonsillitis is actually we can see that we are aware about the tonsils. So it's actually two oval-shaped part available at the back side of the tongue, and it's nearer to or opposite side of the uvula. This is the uvula. The middle part is known as the uvula, and these are the two oval-shaped layer or the pairs that are known as the tonsils. And here you can see that there are the redness present in the tonsil as well as the uvula. So what we are identifying this redness. We are identifying, or we are interested to identify this redness. Now, based on this redness, we can have the answer that person has probable COVID or not. Now here you can see tonsils. This is a real image of the tonsil COVID patient. So tonsil, which is reddish, as well as the uvula is also you can see, which is reddish. So we want to identify this reddish portion. So ultimately, we have developed two techniques. One is very simple image processing technique, because at that time we don't have the data set, as well as we don't have the time to give the solution to the society. So we gave the solution with the help of the simple image processing technique. So before going towards the simple image processing technique, I am explaining you what are the signs that are useful for the tonsillitis detection. So there are actually red or the swollen tonsils. Tonsils can be red, and that is the very important symptom, as well as the swollen. So swollen as well as the redness, as well as the white or the yellow coating. But out of these two, we are interested in the red or the swollen tonsils. Sore throat cannot be identified, and difficult to painful swelling, that is also not identified. But in the later part, we will take fever also. So right now we are concentrating on the red tonsils. In the later part, still we are updating our algorithm. We are waiting for one thermal scanner, means thermal camera, not a scanner, so that we can identify the fever. And there are some other symptoms, but I am not going into depth of that symptom. We have, first of all, as I told you, our tendency is to publish the work in the good journal and the conference before coming to the audience. So this work is particularly accepted in the Springer conference, as well as the Springer Nature Journal, as well as our next work that related to one-shot learning is accepted in the Indicon 2020. So these are the acceptance of our work. Now, flowchart of the work, how our work is actually, how we have demonstrated our work. So here I am explaining you with the help of some demonstration that we have to identify the region of interest over here. So region of interest is tonsillitis plus uvula. That is what our region of interest. So for finding out the region of interest, we have to take the subset of the original image. Original image means we have to capture the inner portion of the mouth, and we have to find from the inner portion only the uvula plus tonsillitis. Then after This region of interest should be robust and vital, that is okay. But the objective is that we want to find out the redness near the uvula and the tonsillitis, as well as we want to remove the unnecessary parts. That is also one of our goal. So the unnecessary part means tongue, teeth, etc. So we don't want that part. So region of interest consists of uvula plus tonsillitis only. So here you can see this is the entire image that we got, and this is the canny edge detector using which we are finding out the edges. This approach is basically related to the image processing. So we use the canny edge detector because it gives the perfect edges. So based on that, we are getting this ROI. This ROI. Okay, but this ROI, as mentioned over here, that it consists of some additional portion also. It consists of lips, as well as it consists of the teeth also, as well as some part of the tongue also. So we want to remove that part. So we have prepared a mask. Mask is just like a template that is rotated on the region of interest, and based on that rotation of the mask, suppose this is my image, and I am rotating the mask on this image from left to right and from top to bottom. Sorry. From left to right and top to bottom. And at some location, I may have maximum similarity over here. Suppose I have maximum similarity, and I have to find out that maximum similarity, and that maximum similarity gives me the maximum correlation. And that correlation, when I am getting, I have to extract this region. When I am getting the maximum similarity, that region I have to extract. That region I have to extract. And now I have to work on this region. So how to work? As I told you, we have to find out the red color. So red color, we use the HSV color space instead of the RGB, because we are aware that RGB is the illumination variant. So we are using the HSV color space so that we are getting the good result. It is illumination invariant. So I am not going in that one, but how HSV is working. So here, suppose we have this region that is the image of the COVID patient. So here you can see that there are so many red pixels, and then based on the number of red pixels out of total number of pixels, we found that person has COVID or not. Here we don't have any red pixel, so person, this image is of the healthy person. Now again, the question is of the data set preparation. So we have total 200 images. Out of that 200, 180 images were classified properly or recommended by properly by the medical team associated with us, and we are dividing that images into the normal, pharyngitis, and the tonsillitis. These are the three levels that in which we categorized our image. Then after, obviously we have the raw images, so we have to do the pre-processing to remove the blur as well as the noise. So we did the pre-processing task, and then after we are giving the images to the our algorithm. Now how we have captured the image, because that is the tough task to capture the image. No one can dare to go near the COVID patient to take the image. So obviously the doctors associated with us, they took this risk, and they gave us some images, but generally we choose this method to identify the or to get the image. Now this is the qualitative results. In some of the images we are getting the correct region of interest, and in some images it is fail. Our algorithm is fail to means region of interest is failed to identify the tonsillitis, and that's why generally people are now not using traditional image processing approaches, because in traditional image processing algorithms we have to dependent on the uh, region of interest detection or the template detection, and that's why we are going for the deep learning method. So sensitivities, now these are the evaluation parameters. These are the same parameters that we used in our chest X-ray analysis also. So here sensitivity we got around 90% only. Accuracy we got around 87%. As I told you, we must have, it should be greater than 90%, but we are getting it less than 90%. So accuracy is also less. F1 score is also less. So this are the things that we have to take care in our modified algorithm. Okay, so in the modified algorithm, as there is a time limit, I am explaining you the modified algorithm in brief. So in the case of the modified algorithm, as we are aware that we have the limited data set, so we work with this motto that less is more, because we don't have any option. So less is more, that is the motto, and that can be useful and satisfied with the one-shot learning. So one-shot learning is actually learning method through which we can identify the uh, particular object or the COVID uh, in a single shot, and that's why it is the one shot. So there is no need of other parameters or the other analysis. So here we have this is just the we can see these are input image, that is the image that is from the data set that we have to give in the one network. This is one CNN network, sorry, and this is the test image that we have to give to the other CNN network. So we have to use two CNN networks, and that is known as the Siamese neural network. It is known as the Siamese neural network. And then after we have to do the similarity check. And the similarity check will help us to identify person as COVID or not. So now this algorithm I am explaining you in very interesting and a simple way. Here we have to just measure the Euclidean distance. And Euclidean distance, if it is least, then we can say that the test image and the image that is given from the data set are same. Suppose I am giving the COVID image from the test training data set, and if the test data set has the COVID patient, then ideally the Euclidean distance gives me the zero answer, and or practically it is in the some range. I have to decide some threshold. So based on that answer, I can say that person has COVID or not. Now, before going towards the network, we have to do the pre-processing of the net image, because in testing data set we have the abrupt image, and the training data set we have some fixed size of the image. So ultimately we want to make the size of the image of training and the testing same. So we are using the bilinear interpolation. The reason to choose the bilinear interpolation is just to reduce the computational complexity. There are generally, basically we have three types of the interpolation: nearest neighbor, bilinear, and the bicubic. Generally we are using the bilinear. Now then after convolution layers, as I told you that we have to use the CNN layer, then we calculate the loss function, and then similarity check using the Euclidean distance. Now Siamese means twins. So we have to use both the layer for the training. This is what the data set, that is the training part, and this is what the testing part. We have to take both these layer networks. It will learn with the two networks, and both the networks have same parameters. That's why it is known as the Siamese. That's why it is a twin. All the parameters, including weight or the convolution layers, or we can say that optimization, each and every part should be same. So CNN. This is what the proposed architecture. In the case of the proposed architecture also, we have used the same network for training and the testing. And over here, we found the Euclidean distance and output decision based on that person is normal or positive. So this way our proposed architecture worked. I'm not going in the detail of this particular architecture, or because generally what I am doing, if I have standalone demo for this lecture, then I'm explaining with the code also. But right now there is no need to go in the depth of the code. Just that's why these are the layers that we have used for our proposed architecture. Okay, now important thing, the training and the validation accuracy. So here we can see that loss is reduced compared to that last algorithm also, as well as the accuracy is also increased nearer to 1. Now sensitivity, it is around 98.4%. In the previous case it was around 90%. Here it is 98.4%. Accuracy, that I am saying that previously it was 87%, now it is 96%. So we have used the same data set, and then also we are getting the good accuracy over here. And each and every part also, PPV is also 97% that we got. So each and everything we got the better in this one-shot learning. Now feature scope can be, we can add, as I told you earlier, we can have the thermal camera. Then we can check both the things together. From the distance, we can measure the throat temperature, because once you have tonsillitis problem, infection in the tonsillitis, then there is a rise in the temperature of around 1 degree centigrade. So we can use this parameter also into the consideration, but for this we must have the thermal camera that we are searching. So this is the future scope. This is the these are the authors that are associated with me. Dr. Upina Dalal, she is professor at NIT. Dr. Mita Paunwala, she is associate professor at Saquib Tauheed. Dr. Parima Parikh is the practitioner associated with us. She is MD and she is with the Biomedical College. And her medical team, all the names are not over here, but she is not alone. Her medical team is also there. Himans Mulchandani and Pujan Dalal, they are my students of the SCAT. And Ojas Rambala is also one of the student of SVNIT. So these are the team associated with me. So I want to acknowledge them. So without them, this work cannot be completed. So these are the some of the references associated with this work. And last slide, that is the Thanksgiving slide, which is most popular slide generally. So Thanksgiving slide consists of 2 email IDs of myself. So if you want to contact me anytime, you can contact me through this mail ID. And I am ready to help always for the any future collaboration also. Thank you very much. That's all from my end.
Okay, thank you, sir. Very nice session. Sir, 2 questions from audience. Uh, Question 1 is, can we add dropout layers in increased convolution layers?
Yes, sir. I have answered to the in between. I have answered that we can add, but there is no need of the adding the dropout layer uh, when we are working with the residual network. So if we don't have the very deep layer architecture, at that time we can add the dropout layer. Right
Okay.
now, there is no need of the dropout layer.
Another question is, are anomaly detection methods useful in this case?
Yeah, it is there, and I answered to the Professor Anurag also that his work is in the seizure detection. It is there. It is possible for his work also, and actually his work is for the time series analysis. So how that problem can be solved using this uh, algorithm, can this can it I have to also look, but it is possible to work that problem to work it is possible to solve this his problem using this technique also. That is true.
Okay. Other methods to class imbalances?
Yeah, that also I have answered to him. There are other methods also of the class imbalances. One I have mentioned that uh, that by adding or removing some of the parameters. And a third method is that if we have more than one classes to identify, uh, here we have only 2 classes. If we have 1,000 classes to identify, and at that time, if we want, if we have the class imbalance issue, then we can have the multiple weights associated with each class, and multiple weights in the sense that suppose class 1 has the maximum images and class 2 has 30% images, 60% is with the class 1, 30% with the class 2, and the 10% with the class 3. Then we have to assign the weight to the class 3 in such a manner that the problem of the class 1 and 2 will be balanced. So that can be also possible with the multiple class. So multiple class imbalance problem can also be solved with the multiple weights balance technique.
Okay, thank you very much, sir.
Thank you.
Um, Good morning, one and all. I, Dr. S. Vagas, on behalf of Rajarshi Shahu College of Engineering, Kathodi, Pune, extends a very hearty vote of thanks to dynamic personality Dr. Chirag Paunwala for sharing his valuable thoughts. Sir, thank you very much for exploring non-invasive COVID-19 detection techniques, convolutional neural network for identify COVID-19, approaches to COVID-19 diagnosis based on tonsillitis detection, uh, and deep learning based approach. Uh, this session has given informative in this regard. Thank you very much, sir.
Thank you very much, sir, and I am thankful to organizer for giving me opportunity to share my knowledge, as well as I am thankful to all the participants to listen me carefully, as well as I am always welcoming all of you to have the future collaboration, because as per my understanding, research cannot be done alone. It should be always collaborative. If you want to do the good research, so it should be always collaborative. So if you are there, then without any expectation of paper writing or that, we can have the future work so that it can be the knowledge sharing. Thank you very much.
Yes,
Thank you, Mandana.
thank you, sir. Very. Over to Bisikar madam. Hello.
Okay, should I leave, sir?
Yes, sir. Yes, sir.
Okay, thank you.
Okay. Thank you, sir. Okay, all participants join at 11:45 for session 2. Okay. Hello, Bisikar madam. Okay, all participants join at 11:45 for session 2. Session 1 is over here.
Hello, Shraddha ma'am. Abu sir, good morning.
Yeah, good morning, ma'am.
So Vaishali Kulkarni.
Yeah, hello, ma'am. How are you?
Hello, ma'am. Yeah, fine, sir. Hello, Bisikar ma'am.
Hello.
Ma'am, can
Abu,
you make sir the co-host?
yes. Abu sir, good morning, sir.
Yeah, good morning, ma'am.
Yes, sir. Here is Dr. Swati Bisikar, sir.
Yeah, hello, ma'am. Swati.
Hello. Sir, we will start at 11:45 sharp.
Yeah, sure.
Yes. Hello, Vibhuta madam.
Ma'am, you have made him co-host.
Yeah. Okay.
Okay. So should I share my screen,
Yeah, sir.
ma'am?
Yes, sir. You can just try out sharing your screen.
Yes, you can see this.
Yes, sir.
Okay, ma'am. So I'm ready. Just let me know when they are back or
Okay.
when we can start. Okay, ma'am.
Okay. Okay, sir. Sure, sir.
Thank you.
Yeah, thank you, sir.
Hello. So with your permission, shall we start?
Yes, ma'am. We can start.
Welcome everyone for session 2 for the day. The speaker for today is Mr. Abu Tauheed sir, founder at Medtiv, Bangalore Urban. Sir has his bachelor's degree in mechanical engineer with a decade of multi-industry experience in product design and development from School of Engineering and Technology. Six Sigma Black Belt certified, 8 years of experience in design and development of medical products, implants, and instruments. Sir has launched 5 products and four new product development are kick-off to launch. Sir has also served as design engineer, technical consultant, project engineer, senior mechanical design engineer in various institutes. His expertise include AutoCAD, manufacturing, pro engineer. Sir has been awarded as Best Team Award and recognized for contribution in top 100 healthcare leaders. Sir has his publications in Balloon Sinuplasty Literature Review and Assessment of Clinical Studies from 2007 to 2018, a real-time sequential phase-shift approach to tetanus cancellation, a pilot study in southern India, design of low-resource, three-way actuated medical centrifuge system for blood pathology test, technical evaluation of AI-based secretion and oral hygiene management systems for ventilator-associated pneumonia, a portable color sensor-based urine analysis system to detect chronic kidney diseases. So, on behalf of JSPM's Rajarshi Shahu College of Engineering and Department of ENTC, I, Shraddha Bhingardeve, welcome you, sir.
Thank you, ma'am.
And I request you to please start with the session.
Yeah. So, good morning, ladies and gentlemen. So today we are going to talk about the body of an AI. So whenever the first thing I want to discuss here is whenever we say about AI or whenever we discussed about AI, people think AI just as an software or something which is like there is some program or something which is artificially running on and it's giving me some kind of prediction or some kind of a extra intelligence analysis, but we never think about what is required to run an AI. And if my AI is capable enough to run anything, do we have something which can run through an AI? So this is the whole idea on which we will be discussing further. So I want it to be keep an interactive session so you can participate. If you want to put your question, you can put in the chat box or even you can just point out and ask the question. So what is an AI, ML and deep learning? So whenever we think about AI, we think, okay, AI is a kind of ML only and it is kind of a deep learning. Everything is together. But if we see, AI is a whole subset. So AI is everything which include AI, machine learning and deep learning. And machine learning is a subset of AI. Deep learning is also a subset of machine learning. But for actual AI, what we need is not the software, because till the time we go to an ML and high-end ML, our software is kind of okay. Our software has reached the only place where we can difference between an ML to an real AI is when the AI will get its body to perform the task through which the machine learning is actually giving him the decision making capability. So when, as we discussed, is whenever we think about AI, we think about software. But what is an AI? AI is a machine ability to make decisions and perform tasks that simulates human intelligence and behavior. If you see, the most important segment of the definition here is something who can make a decision and also perform a task. So now for making a decision, I can build a software. My software algorithm can be so complex that it can take data of, let's say, million people, and then it can take a decision. But to perform a task, my software needs some kind of a hardware to run. So for example, if you see the photo below, it's kind of mimicking an evolution of the robots also. If you see in the last 2 decades, in 20 years, we have moved from a single camera or a single activity robot to now to a multifunctional robots. The robots are able to perform much more complicated and sophisticated tasks. But what is the current limitation, if I ask you, in robotic today's world? Can you guys give me like 1 or 2 points? What is the real limitation you feel like in robotic development? Okay, so the real challenge here is not, we cannot develop something like which is as complex as human mind into a computer. But to run that computer, we need a robotic body which is able to transform itself to the decision and the activation which is coming from the AI mind or a computer. And that's where our real limitation is in building that system which can actually work. Second, I have got some. Ye- So Anurag Verma has said emotions in robot, and that's actually very correct. But even for the emotion, let's say if we see our face, the moment we cry, we laugh, or we show some emotion, there are like hundred of muscles in my face, which is simultaneously acting and depicting what my mind is thinking. But if I have a face which is like totally made up of some one frame, even I can think about emotion, I cannot show. So what I need is something which is so fluidic in taking the action and performing that task. So, sorry. So in the same way, if you see in like earlier last 30 or 40 years, we have seen the development of computers going from a single cell transistor to now like multiple core processor which can run like thousand of tasks at a very high speed. But you see, the processor is kind of a brain for us, which is going in a microprocessor, which is going in a computer, and then that computer is running my robotic arm. But without this hardware, what we can do with the something memory which the processor comes up with, we cannot do anything. So that's where we have to see and understand that AI is just a subset of software, but the real challenge or the real development for AI is depend upon when we build the hardware which can work on AI. To give you a best example, we have is human body. So for a human body, I think everybody knows this, and whenever we discuss AI, the first thing in discussion comes is brain, mind, and human body, because that's what we are setting up our baseline to for an AI. But what exactly is that human mind, brain, and body? So if you see our brain is a hardware or software. It is actually an hardware which is running the software which is called mind. So mind is something which is a superficial thing, which is a kind of mystic thing which is integrated into our brain cells, and the brain is a hardware which enable my mind to fire the neurons at the speed of light, and let's say some billions of neurons at a given point of time, so my body can perform the task. Now imagine if you have the mind which is as sophisticated as our human mind, and you have built a software, and you don't have a brain which can actually take that input and fire your neurons or do such complicated things. What is the value of you our us being developing a mind? And when we talk about the hardware, if you see, the hardware is not just in the nut and bolts. It's we have to think on the hardware which is a way ahead than normal steel and metal. So what is happening here? We have a mind which is subconscious, which we don't know. Everybody has different mind, and they think differently, they act differently, they do differently, they perceive things differently. They have different uh, goals, different roles, and different things. But the brain, which is an hardware, is almost similar in all the human beings, and almost similar a lot of mammals, and there are few similarities throughout all our uh, species, through all the species. So if you see, the hardware remain constant here. You can build any software, but the hardware sophistication is much more required. And now you come to the human body. Human body is made up of bone, vein, artery, skin, muscle, different tissue, organs, multiple different type of organ made of different cells, and everything is living, and everything is controlled by our brain, which is being run through our mind. And why I am emphasizing this point a lot is because when we think or talk about AI, especially in India and subcontinents, based on my discussion, we stop ourselves just thinking about mind. But there is a huge opportunity and huge area of untouched research which is coming to the brain as a software, and then also coming to a body. which can have multiple function, can run multiple things at a given time, and can be then controlled by AI. So if we see our brain, what is our brain? So brain is something which is just a 3.1.5 kg to 2 kg weight, but it has 1 billion of neurons. It has self-healing properties. It can be programmable, and it is plastic yet elastic. What do we mean by plastic yet elastic? Plastic is something as a normal chemical properties or chemistry properties. Plastic is something which you can form and it will retain its shape. Elastic is something which is there. You can extend, you can stretch it, but again it will come back to its original memory. Plastic is something which has an original memory, but the moment you deform it, it will take the new memory. Our brain is also like that. Our brain is a kind of plastic. We teach something to our brain and it remains in our brain, but it gives us enough requirement or enough possibility where we can go and increase our plasticity to elasticity, and we can learn new things. So for example, even at the age of 80, somebody can learn new things, even 90, even let's say whatever a given age, that person can learn any new things and retain it and reperform it. That's what is called plastic yet elastic, because you are still remaining regaining a lot of things which you have learned over the period of time, but still your brain is able to do a lot more new things. But is that my thing is that thing is the functionality of my brain or my mind? That's the functionality of my brain, and brain is not a software, brain is a hardware. In the same way, if you see on the right side of the screen, this is our brain MRI scan enhanced while doing some activity, and the color actually is depicting based on the type of neurons it is firing, type of chemical reactions, and also the type of and the intensity of the electricity which is passing through our brain. If you see this, for running this much complex thing, we need a complex hardware. And that's where I feel like we are lagging somewhere, because our institution also and even industry also don't put that much emphasis on building hardwares. What I believe is we need to move further in increasing our capability in building hardwares which can run as complex software as possible. We are way too far in building software, but we are yet to start building hardwares which are actually smart hardwares. So what is an AI and what we want to achieve with AI and how we can achieve it? That's the biggest question. What we want to achieve with AI? With AI, what we want to achieve it, we want to achieve that human mind cannot be everywhere. We cannot put human mind to everything. Human minds are affected by emotions, and that will actually collate your judging capability and then can affect your outcomes or your decision. What we want with an AI is AI can be free from emotion, human emotion. So we are thinking it will be biased, but we have yet to find out what it will be. But that's our whole aim, is that something which is as smart as human, but don't get overwhelmed by the human emotion reaction and their personal things, and still remain the knowledge and can perform the decision making capability and perform the task which a human is doing. How we can achieve it? That's the biggest question. So if you see in the image, what is an image look like? It look like a simple road with some kind of lines and everything. This is, sorry, this is an design for self-driving car roads, where they have shown how they will put the circuit lines, all the different markers on the road, so the self-drive cars can easily roam. But you tell me, even if I make the some software or something, even if we make a self-drive car, can it drive on a road, normal road, without any accident? No. We need to build smart roads also, so that my smart cars can run and take the commuter safely from point A to point B. So I hope that I have made clear that we now need to focus more and more on hardware as similarly as we are thinking about the software. Because one thing I will tell you, I generally mentor a lot of students, and a lot of students will come by and then they tell that we want to build something XYZ. A lot of good ideas, impressive ideas, interesting ideas, but every idea is limited to my computer. Inside the computer, it either may be some image segregation software, some chemical segregation software, some AI ML based learning things, some kids making a this thing computer game controller through my image processing and other thing. But where are we in terms of something AI which we develop? Can it run on my normal computer day to day? No, I need a specialist device which can go into a medical device. So what is the current application of AI in healthcare? So if you know, currently AI in healthcare is at very limited and early stage. We have a lot of development in AI done in the medical device. A lot of development has been approved, but in terms of adaptability and people actually using AI in healthcare is still very limited. Very limited means less than 2 to 5% of the total healthcare industry. And why is that? The first thing is fear. People fear that AI will take their job. And that's, if you see, is very true. AI will take their job, but we will create another job opportunity, not doing the work which now AI is doing, but making AI. So instead of from making notes, you might move to making robots. You might move to making needles or something else, designing something which a daily productive task can be done by AI. But the major limitation in an AI adaptation is people fearing it will take his job. But the moment you talk to them about the hardware, you are building some hardware, they are okay. They are like, okay, they have seen hardware over the period of time. And until unless that hardware comes in a package with the AI, people will still too much hesitant to use it. But still, we have some application of AI in healthcare. First one is diagnostic and management of chronic disease. That's where we have actually made some dent in that thinking of opposing AI is diagnosis. Nowadays, what is happening is a lot of diagnostic, especially in Europe and US, they are putting a lot of information in a supercomputer on a standard desktop, which has very high processing capability, and they have filled in their whole, let's say, last 10-year database. Based on that database, these computers are now asking the patients based on their symptoms one by one, what is this their indications are. Based on that indication, the hospitals or the computers is making their diagnosis. And based on that, the management is also been decided. And then a senior doctor will see, cross confirm, and then they will give the same kind of treatment to that patient. Now the doctor here is there to maintain that human being who is there, who is taking the diagnostic or who is taking the management therapy for the chronic disease, who gets some good feeling that at least some human being is seeing. But actually the doctor, if you see in that case, is not doing anything. Is just feeling the emotion of the other person of seeing a human being. Because as a human being, we say we like computers, but we don't believe them. That's the reality. And we want to make good computers, but still we don't believe them. And that's where the whole accepting AI, building AI, accepting AI, everything, that cat and mouse game is there. The second biggest influence of AI is coming in medical imagine. And we have been working in medical imagine for AI in around last 10 to 12 years or more than that. And what where it is helping is, if you see, whenever you go to an X-ray, okay, or you go to an MRI or you go to a CT scan, what happens is the CT scan will come to a radiologist who will see your scan and will identify if there is any problem or not. That report will then go to the doctor, and doctor will read just the summary of the radiologist and sometimes see the scan or the X-ray. Let's say if there is a small lesion, which is mixed by radiologist, which is missed by doctor, because radiologist is a human being. He can look at 90% of place, 10% he missed, and there's something very small which is not looking evident, but he also missed, doctor also missed, and then the patient didn't get diagnosed for that. Over the period of time, that lesion become bigger and bigger and become a tumor, and then it need to go to surgery. Where AI is now helping me, AI is now pointing out spots. So I have my X-ray, and there after my X-ray or my CT, the machine AI has already picked up, let's say, these are the points where I see there some abnormality. You as a radiologist now confirm is that machine has captured correct or not. And as more and more we are doing the same thing, the machine is learning things day by day, and then it is improving. But if we remove or if we don't develop our CT machine hardwares as compared to what we are developing in the software, do you think it will be much more effective or least effective if we use the same hardware of the CT machine which we are using today or 5 years earlier, and put more and more complex software which will, like, let's say after 10 years, that will be a mismatch. So you have higher capability, but the machines cannot work. The other thing where we are seeing the AI and flooding of AI is Internet of Thing. Now everything we want to connect with internet. You have some kind of a monitor, it is connected with Wi-Fi so that you can get signal in your phone. And that's kind of a simplest example and simplest application of AI is turning anything which don't have an internet, adding internet to it, and then transferring the data to the required or requested place. Like it can be a mailbox, it can be GSM based technology and sending message to the screen, alert to the user, or some kind of a data sharing. So you have a data here that can be shared to your doctor, your surgeon, and your family members also. The other one is virtual medical assistance. So a lot of time what is happening now is, if you call some call center, you will hear a human kind of sound, but that is not human. That's based on your input that machine had learned over time, and it is giving you answer. And the same thing is now being used in medical assistance to remove, let's say, human hearing limitations, human interpretation limitations, and other things. And the other one place is called self-diagnostic. This area of self-diagnostic people generally tend to overlook. But now, if you see, your phone comes with a lot of things where you can self-diagnose. It comes with a pulse reader. You can use your fingerprint scanner as a pulse reader. You can use your facial recognition software. You can use other things, and the same things are now being developed in different product for self-diagnostics. So there is one company in US who are developing, actually couple of companies, Google is also trying to develop a mirror with an AI. So what will happen is, whenever you will go and see in the mirror, it will scan your face and it will scan for any abnormality. The abnormality can be a small pimple, a lesion in the skin, or a skin defading and showing early signs of any cancer or any kind of a wound, inside wound, or any kind of a skin disease. The other thing is a retinopathy. So when doctors are looking into the patient eye and trying to find out what is the symptoms for, let's say, diabetic, for getting blindness, for other problems, now what we are trying to do is build that whole diagnostic set in a camera, so that you can simply put the camera in front of your eye. Camera can take the picture of your retina, it will scan it, it will populate your kind of a the result they have found it, and then you can share the result directly to any given doctor, and he can see the result and he can give you the exact report for that. But again, if I have a camera which is like very old, it cannot take very HD pictures, it cannot zoom in so close, it don't have a macro capabilities, will I get an image which can be processed and then report can be created? No. So despite we been talking anything, if we don't build a hardware for that, it's going to be there is no value for us just developing a software. Then again, we will limit it to those European countries or other people to manufacture hardware where I can put my software. So instead of them limited to us, now we are limited to somebody else to build the hardware for us. So in terms of some of the devices, if you see the diabetes is one of the problem where the people are trying to put their AI from as early as like 10-15 years. So if you see what is the current problem with diabetes, the current problem with diabetes, and I think most of you will know it, is that your blood glucose level and how much insulin you have to take, and what are the adverse effects. People take standard doses of insulin despite their sugar content going up and down every day, every hour, and sometime every minutes it can happen based on how long you have taken food. If you have taken food, are you taking water or not properly? Is your sleep is proper or not? So there are a lot of variable which if you ask a human being or somebody to take care of it, it becomes too difficult. Now what they are trying to do with this device is it will be continuous attached. If you see on the bottom right hand side, there is a white color, some a small attachment is there. That attachment will go and fix on your skin, and then it will measure your blood glucose level every minutes, and based on that, what is your data? Let's say every 6 hours you take insulin. Based on that input of every 6 hours of your glucose, this device will administer and give only that much of insulin which is required. In case if you need more insulin, it will provide more. It will require, if you require less, it will give you less. In that way, it can control the diabetes much faster as compared to earlier case. Because let's say my body need only 10 ml of insulin, but because of my earlier predictions and when I went to doctor, my body was like showing I need 20 ml of insulin. Now this extra 10 ml of insulin, if I keep giving daily, my body, who is making some part of the insulin, will say stop making insulin because I am getting my whole requirement and extra from something outside. So now my problem of sugar is getting worse day by day. With this kind of a AI devices, we will be able to solve that problem. But again here, the AI is something which is taking data. But if we don't have a device which can give and administer the exact amount of insulin volume and give it painlessly to the patient without patient knowing much about it, or without patient have to like put a timetable on it, there is no use of such intelligence. The other option we already discussed is CT scan. So if you see this CT scan, they have been developing and developing so that the CT scan time is less. If the time is less, the radiation is less. The more less the radiation, the patient adverse effect will also come down. And a lot of algorithm and engineering is been done it to identify the small organ damage patterns at very early stage, which human mind cannot take care of it. What is a future of AI? So in terms of, if I ask you, what you think about AI and what you actually think the future of AI, and when I say future of AI, you give me a definite terms that, okay, tomorrow car or flight aeroplanes can run without pilot. Even for landing and takeoff, we don't need pilot. There is no need to put a pilot inside a cockpit. That's kind of a future of AI, let's say in aviation. So as per you, can you give me like 2-3 example what is the future of AI in healthcare? Okay, so the future which I think, and it can depend upon personally, the future of AI in medical in healthcare is going to be in surgery. Because if you see, surgery is still one of the high risk area part, and in that few of the stages are way too high critical risk as compared to what we knows to them. So if you see suturing is just after surgery, you make an incision and you are just doing it like and closing the escape. That can be sound simple, but it is not. There are huge number of problems which are related to suture, which can lead to resurgery. If the suture is not proper, it can lead to pus, which can lead to then infection of in the wound, and which can even lead to organ transplant going into failure. So what we are trying to do is we are trying to automate the suturing through some way. So here I have few videos which will show how we are trying to bring in robotics to help in the medical health. But where I want you to emphasize more is not to see what is the idea behind or what is the software which is running the program. You just see what are the limitations of the hardware which we have. So let's run on the video and then we can discuss. I have like few videos which we can I want to show you. You can look into it, and based on that we can have few questionnaire and understand more detail about what I'm trying to talk about here. So this is a switching machine which somebody has developed, and he is using a joystick and other things to record first the demonstration, and once it's recorded he want to mimic the same So if you can see, he is actually teaching the robot mimicking every step of suturing. Then he is doing some kind of programming, which is definitely required for us. Sorry. Now he is ready with his experiment. And now I want you to focus on how this robotic hand is moving as compared to how our real hand will move. If you see, the robot can mimic the exact same thing, but how much difficult is this for a robot? Just to move his hand from here to here, he have to take like different angles and arrangement to reach to that axis. Instead of us being human hand, we can do the same axis like effortlessly. And that's where the limitation of hardware comes in AI. So this is another advanced autonomous robot they have made. This robot can perform small skin incision surgeries and other thing. There is still a prototype and they are testing, and I'll say we are still like 5-7 years behind the real robotic surgery actually being performed through some kind of an artificial intelligence. But either it is tomorrow, day after tomorrow, or sometime in future, we will definitely reach there, because that's where everybody is now working on.
So STAR stands for Smart Tissue Autonomous Robot. The goal is to automate critical part of the surgeries.
So really the main idea behind this project is to take the advantages of machines and the advantages of human intelligent surgeons and kind of combine them and see if we can do something that's better than both of those in isolation.
We're one of the 7 centers in the country funded by FDA to support product development cycle for pediatric focused unmet needs. I was doing a fairly sort of unique set of surgery fixing children with airway disease. The challenge that I faced was that I thought that a knowledge that's simply contained within a human being that cannot be transmitted. So that sort of got me thinking that it would be great to program best surgeons' techniques into a machine and have it available. So ultimately democratizing surgery.
The Da Vinci, in the classical sense, you might not even say as a robot because it doesn't have any motions of its own. It's completely controlled. Our system, on the other hand, does things on its own, so it could be considered more autonomous than the Da Vinci.
Current robots on the market, such as the Da Vinci, are completely teleoperated. So that means that every motion of the robot is actually done by the surgeon. So there's no autonomy, there's no intelligence of the robotic system itself. The STAR system is supervised autonomous. So the surgeon, helps with the planning, but then the robot performs the critical part of the surgery autonomously.
When you actually look at surgical tools, the basic mechanics and designs and ergonomics of tools really haven't changed from Roman times to medievals to open surgical era to minimal invasive to Da Vinci as a surgical robot. These are essentially a powered tool that really has no intelligence. What's different about STAR is that it has awareness. So we did a couple of things. Number one, improve the vision part. The second part is we've added some sort of a quasi-haptic or sensor technology, so it feels a little bit rather than not feeling at all. So the idea being that even with a very minimal improvement in vision and intelligence technology, just imagine what it could be in the future if you continue to improve on this.
I think the future is going to be kind of continuing down the path of bringing the benefits of machines and the benefits of humans together to accomplish something in a collaborative manner. I would think that we're going to see a lot of enhancements in perceptive capability of robots and enhancements in the decision-making capability of machines. And so this combined with the surgeon's kind of innate knowledge and training, I think is going to be widely used in the future.
So there are some more robotic videos. Few of them are already present in the market. They are being used in the surgery, and few of them are currently being tested, some kind of a prototype or early stage of implementation. So if you see, this is a surgery. This is a femur bone. I hope everybody know the femur bone is like our thigh bone. And one of the most critical surgery in an orthopedic is femur surgery, because the femur itself, anatomy of a femur itself is very complex. It starts with a head, has a neck, then it has a whole body, which is like twisting angle, and then it comes down to our femur part, our knee side. What happens is when the surgeon want to make a proper cut, he have to dislocate either knee part of the femur or hip part of the femur. And as he is dislocating, he is trying to make as a small incision into the skin as possible so that the healing time can be small. But he also compromises on his ability to see the femur properly, to measure the femur properly, to make a proper and fine cut. How this robot is helping us is it's going in, it is identifying the femur before making the incision, and then it is making an incision as the given by after identification, and then making a precise cut in the femur, which in turn will not only give outcome as a better surgery, but also low recovery time and better rehabilitation time. So this is one of the complex thing to do in a hip surgery. What he is doing now is, since his femur bone is weak and it's been osteoporosis has made it, there is some problem. So the bone is now chipping off, or either his mucosa or his covering on the bone is totally wear off. So the doctor is now drilling into the femur, putting an implant, and he will put a cap. But putting an implant in a bone and rimming is one of the most challenging tasks for the doctor, because they have to plan earlier. They have different kind of implant that need to be put in, and then it need to actually fix properly to the human bone. This is a Da Vinci system. So if you see, I call this, one second, I want to switch off this audio of this video because it's just coming in my thing. Yeah. So if you see Da Vinci robot, I actually call something which is capable enough to be run on an AI, because it's give you so much of flexibility in terms of a hardware that I think it is almost ready to get a mind of itself and start learning, at least in terms of surgery. Because if you see, multiple hands, multiple precision, this is one of the other research they have done to identify how they can apply the robotics into the skin insertion and other things. So if you see, now this robot is capable enough for a soft touch, and it can also make insertion and other things. Now it is making an insertion. In the same way, so Medrobotics actually have designed one new device which actually can enhance now the surgery in the lower abdominal part or inside the smaller intestine, which was earlier not possible through minimum invasive surgery, and the user or the doctor have to choose open surgery, and he have to cut like a 16-inch insertion into the stomach to go into that small intestine. But with this robot, we are now able to capable of doing this with very limited incision. Hair replacement therapy, robots have gone actually too far in hair replacement surgery, and some of the clinics in uh, US and Europe are actually using fully automated robots to identify the skin, identify the grafting area, identify the plantation area, and also do the plantation of the grafts. The other thing is bionics prosthetics. So where is the limitation factor? If you see from very early civilization stages, we have been trying to put some kind of a artificial hand, leg, or some other body parts which will help to perform the task of the amputee better and more efficiently. With the help of AI and with the help of the sensor and the hardwares, we are now able to achieve some of the basic functionality. And definitely with the kind of advancement and research people are doing in that, we have reached to a certain level where we can simply transmit the information just through our mind to even our paraplegic body parts, and then make the movements of the hand and the leg. It is still in a very early stage, but that is coming to a reality.
movements and trigger the hand to respond accordingly. The bionic hand and fingers of the prosthetic are controlled using the same muscles as a biological hand, so learning how to use the device is incredibly straightforward, which is very important for any amputee rehabilitation process. Each hero arm is entirely bespoke. The user's arms are scanned to create a perfect 3D printed socket, providing a comfortable fit that also increases usability. The hero arm comes in 3 different hand sizes and 2 different arm layouts, making them suitable for all ages and sizes. Intended for everyday use, the hero not only gives users the ability to hold objects such as food, tools, utensils, and pens, but also allows them to get dressed easily, open doors, and even type on a keyboard, all essential for boosting independence. It should be noted that the manufacturer advises against using the bionic arm in potentially high-risk situations, in case it fails or the battery dies. This includes driving, any form of contact or extreme sport, and also using a firearm. The Hero Arm has some amazing features and tons of personalization options, but those aren't the only reasons why it's set to become the future of prosthetics. The Hero Arm starts at just $3,000, which might sound like a lot of money. However, comparative prosthetic arms with similar features can often cost skyward of $50,000 and even as high as $100,000. Open Bionics can also fit, print, and deliver a tailor-made arm in around 40 hours, far quicker than any other company. University of Utah's Bionic Leg. When thinking about
Yeah. So to give you what this University of Utah is doing is something very interesting, very trivial, but a lot of people have tend to oversay it or didn't feel it to be a real challenge. What is happening is here is, if you see this, let's say this is the road and this is the person who is walking like this. What he will do is he will lift his leg, put it, then he will lift this leg and then put it here. And that's with this continuous motion, he will be walking. What is the challenge with the prosthetics is, let's say my this finger is prosthetic and this is a real leg, and then I am trying to walk. This leg will walk like this, okay, but this will not walk like this. This will tend to limp and will go like this. So what that thing is doing is, it is not helping you to mimic the real motion and still not helping you to do your day-to-day walking very effectively, because then you can run over by small blocks, which if you don't see it or if you don't lift your leg too much up, so now you have to walk like this and you have to walk like this. So you have to, every time you have to pull this up so that you don't interfere in anything. What this University of Utah is doing, they are building a smart prosthesis which will actually mimic your leg portion, and it will make it move like a normal feet.
prosthetic legs, you might picture a pair of running blades or a metal pole attached to a trainer. But times are changing and prosthetics are evolving. The University of Utah's Bionic research team is at the forefront of prosthetic development, and their latest bionic leg is, by far, their most advanced to date. Technology that allows users to control their prosthetics with exaggerated body movements have been around for quite some time, and even mind-control devices are starting to crop up here and there. But the University of Utah is taking a completely different approach. What if prosthetics could think for themselves? Robotic and AI technology are moving at an alarming rate, so why not implement that technology into amputee prosthetics as well? Dr. Lenzi, who leads the team, set out to make two major fundamental changes. First, to create a powered prosthetic that is lighter and stronger than a biological human leg. And second, to develop a leg that can think for itself and knows how to move naturally in any given situation. The results are staggering, and users are astonished by how different this new prosthetic operates compared to anything else currently available. Dr. Lenzi's theory is that AI-powered prosthetics feel more effortless than those controlled consciously, making them far easier to adapt to. The bionic leg allows users to move around more naturally when doing everyday tasks, such as climbing a flight of stairs, stepping up a curb, even standing up from a chair. And this is just the start. Although Dr. Lenzi's bionic leg is still in the early stages, the development of the technology is still promising. Being lighter and more powerful than a biological leg means that this robotic limb could provide users with abilities not available to regular able-bodied people. Robotic prosthetics such as these could turn those previously considered to be disabled people into amplified bionic humans. Mr. Burkhart's brain implant. Meet Ian Burkhart, a quadriplegic that after a freak accident became paralyzed from the shoulders down. 5 years after his injury, now aged 24, Ian Burkhart has regained control over his right hand and fingers thanks to a new technology that can transmit thoughts directly to his muscles, bypassing his spinal injury entirely. By implanting a small chip into his brain and connecting him to a computer, Ian was able to learn simple movements through multiple sessions of thought repetition. By focusing his thoughts and through doctor analysis, Ian was eventually able to do tasks such as pour water from a bottle, pick up a straw, and even play Guitar Hero. Getting to this level of movement took over a year of continual learning and countless sessions, but progress is now speeding up. The system works somewhat like AI, except Ian's brain is doing the teaching. When Ian thinks a thought, such as opening his hand, neurons fire that command off in his head, but because of the spinal injury, the signals can't make it down to his hands to perform the movement. The implanted chip picks up on these neurons and sends the information to the computer. Through repetition and visual learning, the computer learns that certain thought patterns mean specific things, such as opening and closing Ian's hand. Once the computer understands Ian's messages, it can send the commands to another device attached to his hand, triggering the hand muscles to move. While this technology is not exactly a bionic prosthetic, it does allow paraplegics to regain control over their previously dormant limbs. As it stands, the technology is only capable of very simple movements and tasks. But in the years to come, people such as Ian may be able to regain control over their entire arms and legs, and may even be able to walk again. Osteo's mind-controlled bionic prosthetics. While there are a small number of companies developing mind-controlled bionic prosthetics, Osteo, the global leader in non-invasive orthopedics, was the very first. Back in 2015, Osteo provided two amputees with the first prosthetic legs that could be controlled with thought alone, and their technology has been getting smarter ever since. Bionic prosthetics typically require a certain level of conscious input or intentional thought by the user. However, Osteo's smart limbs are capable of doing all the thinking themselves. Through real-time learning, the smart bionic legs can adjust to their user's walking style, speed, and terrain, making for a natural and intuitive user experience. The technology works by picking up on natural movement signals and replicating how the body translates electrical impulses into specific muscle movements. Electronic impulses from the brain are received by sensors embedded in the existing muscle tissue, which then translates said signals into the appropriate bionic limb movements. The process is instantaneous, resulting in seamless and perfect physical movement of the prosthetic and user. Through the use of Osteo's technology, users no longer need to adjust their equipment on the go or put up with the chronic injuries associated with traditional prosthetics that are unable to adapt. Biodapt performance prosthetics. Okay, this prosthetic might not be robotic, mind-controlled, or work with AI.
So this prosthetic, what they are showing now, is actually very interesting. If you see closely, it is pure mechanical prosthetic. There's no intelligence in it, but it's give you the capability or the hardware where you can actually put something, a smart software, a smart chip inside it, and it can transform. So this guy who has lost his leg in a extreme sport, he went back, he designed a prosthetics which can be used in extreme sports, and now a lot of people are actually using these prosthetics in, let's say, extreme sports, bike running, skiing, and other things.
But it was still far too innovative to leave out of today's video. Biodapt designs and manufactures high-performance lower limb prosthetics for action sports and similar activities.
You see, this rider is
Biodapt's
missing
goal
one
is
leg.
to not only get amputees moving again, but also to have them moving freely and enjoying life to the fullest without limitations. Their amazing prosthetics can be and are used by many elite athletes competing at the highest level, as well as people who simply want a quality limb solution that allows them to enjoy a range of activities. Professional snowmobile racer Mike Schultz started the company after losing his leg above the knee in an accident back in 2008. After recovery and rehabilitation, he quickly found out that there were no prosthetics available on the market that allowed him to ride and race as he did pre-amputation. So he decided to build one himself. With a wealth of fabrication knowledge, suspension tuning experience, and unwillingness to compromise, Mike created the first prototype version of Biodapt's commercially available prosthetic. Named the Moto Knee, this prosthetic looks like a motorcycle part in its own right, with fully adjustable shocks, air springs, and a unique linkage system. The device gives users a uniquely natural and dynamic feeling that is difficult to replicate. Biodapt also offers a foot and ankle prosthetic that can be used in partnership with the Moto Knee. Mike has gone on to win multiple ESPN X Games medals while using his prosthetic leg, and a number of other athletes have also followed in his gold-winning prosthetic footsteps.
So what is the future of AI in healthcare? The future of AI is very big. There is lot of scope of development. Everything which we do today can be moved to an AI based system, and we can actually explore and bring in much more items into that AI and healthcare. But we have to choose very efficiently and smartly what things which we want to work in, how that can become an independent entity, and how that can help to the society. So if you see, the first one is definitely robotic assisted surgery is the thing of next 10 years. Virtual nursing assistants, administrative workflow assistant, this is one of the other place where a lot of research is going on, and how to do the better implementation without being getting that human being who is using it to at irritation level. Fraud detection, a lot of medical healthcare departments or the people's work on like fraud care. Fraud detection is like, is the insurance claim is fraud, is the document is fraud, is the doctor did some fraud, hospital did some fraud. Everything can be assessed through an AI, through multiple pattern, through camera, through recognition, through various other parameters. The other challenges are doses error reduction. What happen is, over the period of time, the same doses cannot is not required by the same patient who is taking it like 1 month ago. But instead of going to the doctor, the patient sometimes carry on to the same doses over the period of time, which in turn either suppress their immunity, some kind of a fight backing capability of the body, or they can put a additional secondary risk as a side effect. Connected machines, so hospital have like hospital or any healthcare place has like thousands of machine. Everything is just giving their data input alone. What we can do is we can collate all the data, put it on a dashboard, and then the hospital or the nurse can directly see everything on a one dashboard. The other thing is clinical trial, preliminary diagnosis, and automated image diagnosis. So these are only a few points which I have listed, but whatever and whichever thing you can imagine can be put in AI. But where my whole personal interest is with building software of AI, we should also think what kind of hardware we need to build. So, and in also in terms of when actually motivating our students to do some kind of innovation, always try to teach, I always try to expose them more to the hardware kind of an experience or is just to build better hardware with the help of software. So with this line, I would like to conclude my talk. And okay, I am like 5 minutes extra. So we have 10 minutes for question and answer. I am like open for any kind of questions you can ask me. Yeah.
Hello, sir.
Yeah.
Hello, myself, Dr. S.C. Wagal.
Yes, sir.
Sir, one question from audience.
Mhm.
Hello.
Yes, sir. Yes, sir. Tell
Uh,
me.
uh, what is the minimum computer configuration required to running deep learning algorithm?
So, yeah, I got that message also on the chat. So, when you want to run a deep learning program and what kind of computer you need is kind of a very vague question. The deep learning, so for example, when you are saying deep learning program, I am understanding the data set is very huge. You have to run the program for a longer period of time. That's what I'm saying. So the first thing is I never suggest people to run deep learning or an ML on a laptop because your laptop is designed to be mobile. It need to go everywhere and it need to be light, and that's where the manufacturer always compromise on your heat exchange capability or your working capability of a laptop. So the always the best thing is make a desktop. It will be much more cheaper. It will be at least 30 to 40% cheaper than a laptop if you build a desktop, and it can be at least twice or thrice as powerful in the same money. If let's say if you buy a Xeon processor which is like good enough to run any kind of an institutional academic deep learning softwares, you put let's say 32 GB RAM, 40 GB RAM, couple of uh, uh, graphics cards you have put, and that can run. But the same kind of thing, if you want to buy get in a laptop, it's required you like to put like 3-4 lakh rupees in the laptop. So I never suggest to run on the laptop. But still, if you want to run on laptops, there are few laptops which are good enough. Like now, the Intel has come with the i9 processor, which are especially designed for high computing programs on running on the laptop. Use that. Use some laptops which are actually thicker in size, not thinner, because the moment you start processing that processor on a very high speed, the processor will get heated. It will distribute the heat on the motherboard, and over the period of time, if you are running such thing on your laptop, your heat sink will either get damaged, or your heat, there is a gel which is for heat transformation that will vaporize, and then you have to go in the servicing of the laptop. So either use industrial grade laptop, or the best thing is if you want to do in a college or for yourself or a department, buy few desktop computers, use it, connect it with the cloud, put your also data or the software on cloud, which you can go and check remotely through internet. But don't run the whole system on the laptop. That's how I will tell.
Okay. Okay, sir. Thank you.
Yeah, but if
Any,
you want to still use on laptop, use multi-core, at least 6 to 8 core. Use multiple RAMs. So instead of one RAM of 32 GB, use two set of RAM for 16 GB. It'll always help you to work very efficiently. Instead of one RAM, you have two RAMs or three RAMs. Increase the cooling. Put that laptop in an AC room where the temperature is actually controlled, so your whole electronics don't get heated up.
any question from my audience? Uh, okay, sir. Okay, all of you send your questions through email also. Sir,
Yes, yes. So I have, you guys have my email ID. You can take it. You have my phone number also. Any case, if you need anything, any kind of information support, I am there for it. But the only thing I would like to request you guys, and generally I do this to all the faculty member which I meet. Whenever you give project to the students,
yes.
always try to see if they are learning hardware and software both, because I am seeing this trend. from my college days to till date, where is like a decade has been passed, we are just emphasizing too much on the software, and that's where our hardware is very limitedly developed. So I want, at least from our teachers who are actually the building block of future, all of you are the building block of future, not me, because I am sitting in some kind of a isolated cubicles. You are there on the field developing those students every other day, motivating them. So I want you to motivate them also to build hardware, also to cross collaborate. Like you make projects where you put different industry people, electronics two people, mechanical two people, biomedical two people, let's say some two of the chemist also, two of the physicist also, so that a group of those individual will be able to perform a project much more efficiently and much more better as compared to few people of a single trade coming out to something. So that would be my one request for all of you.
Okay, sir. Very nice information regarding project also. Okay, actually students will done project in this area, robotics area.
Yes, yes,
Okay.
yes, exactly.
Yes, sir. Uh, Thank you very much, sir.
Okay, thank you very much.
Good afternoon, one and all. I, Dr. S.C. Vagas, on behalf of Rajarshi Shahu College of Engineering, Kathodi, Pune, extend a very hearty vote of thanks to dynamic personality Dr. Tauheed for sharing his valuable thoughts. Sir, thank you very much for exploring application of AI healthcare diagnosis and management of chronic disease, smart tissue autonomous robot and full robot, and bionics prosthesis by mind control, assisted surgery, fraud detection, and automated image diagnosis. Okay. This session has given informative in this regard. Thank you very much, sir.
Thank you very much, sir. Thank you very much.
Thank
Okay.
you, sir.
Thank you,
Okay.
sir. Abu sir, thank you very much.
Yeah, thank you, Vaishali ma'am, and thanks you everybody for patiently listening and supporting it. And I hope I was able to justify that time for of you guys for listening to me. Though I feel I am like very much limited in knowledge as compared to you guys.
Yes, yes, sir.
But still, thank you very much for listening and giving the opportunity to speak in front of you guys.
Thank you,
Yes,
sir.
yes,
We
sir.
hope the same in the future also, sir. The cooperation from you for the students also.
Yeah, sure. And also, we are always open to take new interns for the last year project. I love to teach and guide them to give them some industry understanding, how the industry is working and what kind of work industry is looking for, to ensure that they are well prepared after the project to go for an interview and clear the interview. So we are open for internship in terms of mechanical and electronics student and biomedical students. If any one of the students need internship, they can reach to us, and we can help and support them.
Yeah, sure, sir. Thank you, sir. As we are in the journey of autonomy, so we require this internship for our students from third year onwards.
Yeah,
So,
definitely. And I seriously appreciate those college who start the internship as early as possible, because just going for a week and sitting in the office will give the perspective of a student. Okay, the industry work on like this. So I, instead of me, if I don't like few of the things, I can focus on few things and build my career also around that.
okay, sir. Thank you
Okay.
very much, sir.
Sure. Thank
Once
you very
again.
much. Thank you,
Yes.
ma'am. Okay, bye.
Yes. Bye.
Uh, Over to Bisikar, madam.
Yes, sir.
Uh, any instruction for participant? Next session.
Tell the participants to join at 2 p.m. for the next session.